We recently had this question on our discussion board. Can DataGraph automatically find peaks? And you can see an image here which was posted. This is extremely helpful to have a copy of what this user is working on, where it seems as though they want to have an automatic way to draw a line along the top of this signal. And I will show you exactly how to do that. In fact, I have a simple example that I created. And in this example, we're going to go ahead and take the made-up data that I have here. I'm going to show you how to find the maximum values along the signal. We're going to plot a line along the signal as well, or along the tops of the signal. This is actually plotting the actual from tip to tip. If you want to do something a little smoother, you could use a polynomial fit, and I'll also demonstrate how to do a low order fit like you see here, this LOESS fitting. Okay, so let me go ahead and get started and show you how to do this. And I will share my screen. So this is the file where I created all of these. What I want to do though is let's go ahead and start completely from scratch so that you can see how I did this step by step. I just copied this data into my clipboard, edit copy, and then do a new DataGraph file, and I'll just paste this data into there. First step, finding the maximum value. To do that, I'm going to go ahead and use the plot action column. But first, actually, let me just to have this handy, we'll plot our data. Oh, and there's one thing actually I wanted to show you, and that is I often like to remove this padding on the right-hand side. I think that sort of looks nice for data that looks like this. And there's two ways. You can go into the axis settings, and there you'll find the padding settings for both X and Y. A handy shortcut is just to go down to your axis line and right click, and you'll see that the axis padding setting is there. If you set that to none, now it extends the entire length of the axis, which again, I think looks kind of nice for data like this. Okay. So now, again, finding the maximum value. I'm going to do this actually in the data table. Come over to my column list and choose a plot action column. Once you have that created, you'll notice that there's a couple of things we need to populate here. We have to choose our X and Y. We have to choose the action we're doing. And I'll just go ahead now and choose the extrema. That's what we're going to want for this. That then adds some additional options that are specific to that action. But in terms of populating the X and Y, again, I always like to demonstrate the ability to drag and drop. And right away, you see, once I've done that, now I have some values populated within my data table. What they're actually returning here, if you look at this, is the X value. And in fact, that is an option within the plot action column. It's returning X value, but I can change that if I would like to return Y value, which is sort of what I like for this example. And then this is my max values. So you can see throughout this data, the max values and the row that they're associated with. But let's go ahead and actually plot them to make sure that they're where we think they should be. So first I'll just clone my graph that I started with, and to plot, we'll go ahead and I'll just select both of these columns, and we'll add in a points command. I'm going to change the color of the fill to red and increase the size of this a little bit. And right away, you might notice that there is a point down here in an area where I actually don't want a point there. Other than that, this looks great, right? This is finding all of my maximum values. So why is there this point there? Well, this is where it's a great opportunity to demonstrate how the loop tool works. And I'll have to disappear here for a moment to show this to you. This is over here on the top right, called loop, and if you click on this and then go down to your graph, you see how you have this magnifying glass. So if I put this right on that point and I can zoom in and out, basically I have a touchpad and I have two fingers. If I move down, it gets smaller. If I move up, it gets larger. I can also move side to side, and that also changes the size of the magnifying area. In any case, when you look at this, you can see that sure enough, there is a local maxima here that the plot action column is picking up on. But we don't want that. And so to have it not consider that local maximum, this is not a difficult thing for us to do. Go ahead and bring myself back here. To do this, we're going to go over to the window. By default, when you are looking for an extrema, the window is set to 0, which basically means it's finding everywhere that there's an extrema value, whether it's a maxima or a minima. And if I change this, then it's going to suddenly use a window environment. And sure enough, just making the window a little bit away from 0 means that I no longer have a value being targeted in that data. So now this looks good. And you can type in an exact value here. I often like to just use the slider to kind of find where it makes sense, but then type in an exact value. Okay, so now I have my maximum points, and how can I plot them? I'll go ahead and clone this graph, and we're not going to use the points for this. Instead, I'm just going to actually plot all of I can use the entire X column and my max column and use the plot command. Okay, I did that, but why don't I see anything? Well, the reason I don't is because the plot command is actually set up so when you have gaps in rows within your data table, like we do here, it does not connect these points by default unless, it doesn't connect them by default no matter what. But if you want them connected, there is an option for that. Expand the plots command and you'll see this option for bridge gaps in data. I click that, and sure enough, now I have a line that extends across the top of my data. And you can make that a smooth line if you would like, or leave that to be a straight line where it's connecting the points. Again, I'm going to just invoke the loop tool for a moment here to just show you now how, sure enough, all across the tips of these peaks, there is a line connecting those locations. But what if I don't want to connect the tips? What if I have a little bit of noise in my data, and what I really want to do is just have a smooth line that represents the maximum of my data? I can do that too. In fact, let me not do a new graph. I can just keep cloning this, but doing slightly different things. I can hide my line here. Actually, I think I'll just hit the delete key, get rid of it. And now, again, I'm going to do a fit. I can select my data, click on my fit command, and change this from a linear to a polynomial. Actually, the fifth order polynomial does a pretty nice job of this. Oops, that's not the one I meant to turn red. Let's make my fit line red here and increase the size of this so you can really see it. So I can change the order of my polynomial if I like to get a different fit. But again, if I invoke my loop tool, one thing about doing the polynomial fit is that you have the potential to get oscillations, particularly towards the edges of the fit. So if I want this to be, a bit lower, that looks much better. But depending on your data, maybe the polynomial isn't the way to go. So the other technique that I tend to use for something like this, where I'm just, again, trying to show a nice trend with my data, I'm not really looking for an actual function per se to come out of this, but you can change the fit type to the LOESS fit. This is a low order fitting approach where you won't necessarily see those oscillations because it is a local type of regression along the data. And it has a bunch of different smoothing options. By default, it's a second order. If you change it to a first order, then the lines tend to be, a little bit smoother, but again, if you have some actual oscillations you want to more curvature, then you can, stick with the second order. And both of these have the option of either just using a slider to define basically the window that's being used for that fit, for that local fit, or you can change it to what we call the radius, first radius or second radius. And when you do that, by default, it is set to this 0.3 of a width, just to let me turn off the loop for a moment, just to give you a good initial guess, but you can type in anything you want for this. So if you wanted this to be much a specific value, bigger, smaller, you could change that. You could also make this a variable and then set that into another slider if you would like to see the value. So in any case, I hope that this is helpful. Absolutely, this is a technique that you can use and set up in order to go from your signal and finding those maximum values, plotting a line across them, and then also coming up with a smooth fit of that data. And you can do the same with the minimums as well. If you were looking to find the minimum value, you can see here how if I go back into my plot action, if I change this to minima, now look at that. It just changed everything. Since this is a pipeline that I've created here, it finds the minimum values and does the same thing in these other graphs. Okay, so again, hope this was helpful, and keep the questions coming.